So today we're going to talk about powers and radical functions. Most of this you've learned before in Algebra 2. There's basically two parts to the lesson today. One is on graphing and the other one is on solving radical equations. So here we go. We're going to talk about graphing and analyzing a function. So if I have my function f of x equals 1/2 x to the 6th, we could graph that not using the calculator, but actually do it by hand. We could talk about making a table. If I make a table, I would be able to figure out exactly what x could be and therefore also find out what y could be. Our domain, since x could be basically anything, our domain would be all reals, from positive infinity to negative infinity, or the other way around. Our range, no matter what number I'm going to put in for x, I'm going to get a positive number because it's a variable raised to an even power. So that means my range is going to go from 0 to infinity. My intercepts I could find by figuring out where it's going to cross the x-axis through my table. And then I can find out my end behavior. Remember, we kind of talked about that last year. And then continuity as well. So there's my table. If I've completed my table, that would be what I have. Notice that our end behavior tells us that as x goes to negative infinity, our graph is going to go to, sorry, as I'm trying to get my pen here, our graph is going to go to positive infinity because it's getting quite large. And as x goes to positive infinity, y is also going to go to positive infinity. And if I look at the graph, there are my answers to all my questions there. There's my domain going from negative infinity to positive infinity. There's my range going from 0 to infinity. I can figure out that I'm going to have an x-intercept from my table at 0. And then I can talk about my end behavior, both of which are going to positive infinity. I can talk about it decreasing from negative infinity to 0, and it increases from 0 to infinity. Notice this time we're also using our interval notation as opposed to using our inequalities like we did last year. But basically, we talked about all of this type of things last year. Here's another equation, and the only thing that's different is this time it has f of x equals negative x to the 5th. So if I look at my table, I can see that as I'm going from the left side of the equation, I'm getting my numbers that are getting smaller on this side. And if I'm going here, these numbers are also going smaller, so they're both approaching 0. But these numbers are getting, as I'm going larger in this direction, my numbers are getting smaller and smaller on the negative side, and as I go to negative infinity, it's going up. So you can see that that's going to be a little bit different. Again, still, I'm going to have an x-intercept at 0. So if I were to look at my answer, my domain is going to go from negative infinity to positive infinity because there's no denominator to take out any of the numbers to make some sort of discontinuity. This time my range is going to go from negative infinity to positive infinity. Our intercept is going to be at 0. As x goes to negative infinity, as x goes to negative infinity, y is going to go to positive infinity. And as x goes to positive infinity, y goes to negative infinity. And we know that it's going to be continuous, and it's always going to be decreasing because it's always going down. Now, if I start looking at something that's like this, I'm going to have, because of the negative exponent, I am going to have an x in the denominator of the fraction. So now we can start talking about where things are going to be undefined. Well, it's going to be undefined when x is in the denominator of the fraction. Don't forget, this is going to be 2 over x to the 4th. So when it's 2 over x to the 4th, I'm going to get a 0 when x is 0. So that tells me it's going to be undefined. So it's going to have some sort of discontinuity there. If I look at my table, I can see that it's getting larger and larger as I go along here, as I approach that. So that's probably going to tell me I'm going to have some sort of infinite discontinuity. My domain would be everything except 0. And then I'm going to look at the graph to kind of give me the rest of the range and the intercepts and the end behavior. So there's my graph. If I look at my graph, I know my domain tells me that it can be anything but 0 because at 0 my graph is undefined. I can see that my range is going to be anything that's going to be greater than 0. So between 0 and positive infinity. I can see that there is an infinite discontinuity when x equals 0. I can see that it's going up, so it's increasing between negative infinity and positive infinity. or sorry, negative infinity and 0, and it's decreasing between 0 and positive infinity. I think that's all that they needed there. Oh, that's right. And our end behavior. Our end behavior tells us that as it's going to the left, this way, it's going to end up being 0. And as I go to the right, it's also going to end up being 0. So here's the same type of idea this time, except now I have 2 over x to the third. So since I have 2 over the x to the third, again, wherever I would have a discontinuity, wherever it's equal to 0. So there's going to be my number that is equal to 0. And I still have my domain and my range and my intercepts and my end behavior. So I can still create a table, and the table will help us to find our graph. So here is our graph. And if I look, notice that my domain is everything but 0. So negative infinity to 0 and 0 to positive infinity. My range is going to be everything. So I'm going to have everything except for 0, of course. So my range would go from negative infinity to 0 and 0 to infinity. Hey, there's that u again. And then there's going to be no intercept, no x-intercept, and no y-intercept because it never crosses the axis there. I also know that my end behavior tells me as x goes to negative infinity, y is going to go to 0. And as x goes to positive infinity, y is also going to go to 0. There's also an infinite discontinuity, and it is always decreasing because it's going down here and it's going down here. So that's kind of the graphing part that we did, and we did that all pretty much last year. So that's not really anything new. This is in your book, so you can look at it a little bit better. If I have something that I have a positive value, my positive for my variable exponent. So if my exponent is positive, if it's even, it will look like that. And if it's even and negative, it will look like that. So we're talking about something like a parabola. So if we're talking like an x to the fourth or an x to the sixth, if it's got a positive a value, it will open up and have all of those properties. And if it has a value that is negative, it will open down and it will look like that. As opposed to something that looks like this, where if I have an odd exponent, if I have an odd exponent and it's an positive leading coefficient, then that tells me it would look like this. And if it's an odd exponent with a negative leading coefficient, it would look like that. And I'm pretty sure that that table is the same table that we had last year in our book. I don't think that's even anything different. But you can look in your book for more specifics on that. But then if I have graphs, I could have a graph that looks like this. Remember that this means that I'm taking x to the fifth and I'm taking then the fourth root of that. So if I were to make a table, there's what my table would look like. Notice that my intercept this time is going to be at 0. Kind of think to yourself, why wouldn't I have negative numbers in there? Well, probably because if I were to put negative numbers in there, I can't take the fourth root of that because that would give me something that's imaginary. So now we're only talking about positive numbers. So that's kind of going to give you a hint on what the domain is going to be. And then we can talk about the range. So once I have my table done, I can graph it. And once I graph it, you can see that it's going to look much like that. So that tells me my domain has to be numbers that go from 0 to positive infinity, and my range is also going to go from 0 to positive infinity. Notice that it can include 0 because I can take the fourth root of 0. As x approaches infinity, y is going to approach infinity. It's continuous between 0 and infinity. There's no discontinuity going on there, and it's always increasing. Here's another one, except this time I have a negative exponent. So think about what a negative exponent will do. A negative exponent would move all of that to the denominator. So once I have that to the denominator, that means I'm going to have 4 over x to the 2/5. So that tells me right away that I can't have a 0 in the denominator. So that's why I have something that is undefined. From there, I would make my table and my graph. And when I make my graph, it's going to look like this. So notice that my domain goes from 0 to infinity. My range goes from 0 to infinity. This time it can't include 0, so that's why we include we put the parentheses in. It can't include 0 because it would be undefined there. There's no x-intercept, as you can see. As x goes to positive infinity, y goes to 0, and it's continuous on the interval 0 to infinity, where it's also decreasing. If I had something like this time I'm going to have 5 times the square root of 2x to the third. Notice that it's not quite x to the 3 halves, although I could write the x to the 3 halves, but the 2 is also to the 1/2 power, so that's why it's a little bit different. Again, I'm taking a square root, which has an index of 2, so that means I can't have a negative number because that would make it imaginary. And since I have an x to the third, and if I took a negative number and raised it to the third power, it would be negative. So I can't have those. So that sort of changes what our graph is going to look like. So here's our graph. It's kind of small, sort of pushed in there. Notice how my scale is a little bit different. My domain goes from 0 to infinity because this time I can't take the square root of a negative number. And my range goes from 0 to infinity as well. I can see I do have an intercept at 0 though, because I can take the square root of 0. As x goes to positive infinity, y is going to go to positive infinity. And again, it is continuous between 0 and infinity, where it also increases. And here's another one. You're kind of getting the idea that a lot of these graphs kind of look the same. They're just slightly different. So if I have something like this, I am going to have 1/2, and I'm taking 1/2 times the 5th root of 3x minus 4. Remember that since it's a negative number and the index is odd, I am allowed to take the 5th root of a negative number. So now I can put negative numbers into my equation. So when I graph it, I'm going to have a graph that's going to look like that. So that tells me my domain goes from negative infinity to positive infinity. I know it's going to be continuous for the whole thing. My range is going to go from negative infinity to positive infinity. It will eventually get larger as the numbers get larger. My x-intercept is going to be positive 4/3, and I can certainly find that by setting the inside of the square root equal to 0 and solving for x. And then I can find out what my y-intercept is if I plug the 4/3, if I plug a 0 in and solve for y. That's going to be a little bit more difficult to solve for though. And then I have all the other answers that are right there. So again, in your book, you can see that if I have, and these are the general terms of the equations, if I have an even index, it would look like this with all of those, with all of those qualities that are there. If I have an odd index would look a little bit different. Notice that an odd index includes the graph that's over here in the third quadrant. Okay, and it also has a little bit of a different end behavior as well. So that's basically the graph portion of the lesson. The second part of the graph of the lesson talks about solving inequalities. Nope, sorry, one more time. Solving radical equations. So when I have a radical equation, it would look like this. Remember, the goal in a radical equation is to isolate the square root. So I'm going to move the 3 to the other side so I can get the square root of 28x plus 29 to the other side. So there, that's all by itself. So I'm going to get rid of the square root. In order to get rid of the square root, I'm going to square both sides. So when I get square both sides, remember I'm taking 2x plus 3 times 2x plus 3 and FOILing that. So that gives me the 4x squared plus 12x plus 9. Then I would set the equation equal to 0. I would, once I set it equal to 0, I would take out the greatest common factor and then factor the trinomial of x squared minus 4x minus 5. And then I would solve those little parentheses to get x equals 5 and x equals -1. But I have to find out if those actually work because I could have what's called extraneous solutions. So what I'm going to do is I'm going to take those numbers and substitute them back into the equation to see if they still work. So when I do that, I can plug in the -1 and the 5. So if I plug in 5, I would see that 10 equals 10. And when I plug in the -1, I can see that -2 equals -2. So therefore, both of those solutions do work. Sometimes one solution works, sometimes both solutions work, sometimes neither of them could even work. But you do need to double check by substituting them in to make sure. Now we're going to do the same thing, but this time we're going to have a cube root. So I would isolate the radical. So I'm going to move the 8 to the other side. From there, since it's a cube root, that means I'm going to cube both sides. So that means 4 to the third power is 64. And then I'm left with x minus 2, quantity squared. So then in order to get rid of that little index of 2 up there, exponent of 2, I'm going to take the square root of both sides. When I take the square root, remember I have to have a plus or a minus because it could be positive 8 or it could be negative 8. And then from there I would solve. And so I get two answers again, x equals 10 and x equals 2. But then I need to verify to see if they're going to work. And when I plug them back in, I can see that both of them, in fact, do work in this situation again, and 2 solutions are our answer. And the last one, this one's a little bit trickier. What you need to do is you're going to isolate one of the radicals. So in this case, one of the radicals is already isolated. So I'm going to take it and square both sides. When I square this side, I'm going to have to remember that I'm going to FOIL 1 plus the square root of 2x minus 12. So when I square that, I'm going to end up with this. From there, I want to isolate the radical again. So I'm going to move the 2x, the 1, and the negative 12 all over to the left-hand side. When I do that, I'm left with negative x plus 12 equals 2 times the square root of 2x minus 12. I want to get rid of that radical, so I'm going to square both sides. Remember, when I square both sides, I need to square this 2 as well to get me a 4. And then I need to FOIL on the left-hand side. Once I've done that, I'm going to have to distribute that 4, and then I'm going to set the equation equal to 0, and then factor, and then set each little part equal to 0. And when I do that, I'm going to get 2 answers. The 2 answers that I get are 8 and 24. You need to actually substitute them back into the equation. When you do that, the 24 does not work. So that means the only solution in this case is going to be 8. So hopefully that gave you a good introduction of what we're going to be doing. Make sure you then fill out the Google form, and I will see you in the next class so that we can start going over some more of these questions in depth. Thanks. Bye.